Have you ever wondered how colossal tower cranes are skillfully assembled and dismantled through precision engineering, daring teamwork, and flawless coordination? Let's explore this fascinating process together. The assembly of the J600 tower crane begins with careful preparation of the construction site. All crane components are delivered and laid out in an organized sequence near the foundation area. Technicians first verify that the concrete base and anchor bolts are correctly installed and fully cured. Once the site is ready, a large mobile crane is positioned next to the foundation to begin the main lifting operations. This auxiliary crane plays a central role throughout the entire erection process. The first major step is lifting and positioning the initial mast sections. Each section of the vertical mast is a heavy steel structure that must be handled with precision. Rigging specialists attach lifting slings to the first mast segment, and the mobile crane slowly hoists it into a vertical position. Ground workers guide the load carefully to align it with the base anchors. When the section is accurately positioned, it is lowered onto the foundation and temporarily stabilized. This forms the starting point of the crane tower. After the first section is secured, additional mast segments are installed one by one. The mobile crane lifts each section high above the previous one and lowers it into place. Workers positioned on elevated platforms guide the components so that the bolt holes line up perfectly. Once aligned, high-strength bolts are inserted and tightened using torque tools. This connection process is repeated for every mast segment, gradually increasing the height of the crane structure. Constant checks are performed to ensure that the tower remains perfectly vertical and stable. With several mast sections already assembled, the next critical phase is installing the slewing unit and the tower head. The slewing unit is the rotating mechanism that allows the crane to turn during operation. Because it is a complex and heavy component, it requires extremely careful handling. The mobile crane lifts the slewing unit from the ground and raises it slowly to the top of the mast. Technicians stationed at height guide it into the correct position. Once it is seated on the final mast section, it is firmly bolted down and connected to the structural frame. Immediately after the slewing unit is secured, the tower head is mounted on top of it. This upper section forms the main connection point for both the jib and the counter-jib. As with previous components, the tower head is lifted by the mobile crane and carefully positioned. Workers align the connection plates and insert large bolts to lock it in place. Electrical and mechanical connections are also prepared at this stage, as the tower head will later support the crane's control systems and cables. The assembly process then moves to the installation of the jib, the long horizontal arm of the crane. Because the jib is very large, it is usually assembled in sections on the ground first. Several segments are joined together to form the full length required for the project. Once pre-assembly is complete, the mobile crane lifts the entire jib structure as a single unit. This is one of the most delicate operations, as the long component must be kept perfectly balanced while being raised into the air. As the jib reaches the correct height, it is slowly maneuvered toward the tower head. Workers positioned on the structure guide the connection points together. Large pins and bolts are inserted to attach the jib firmly to the slewing unit. Additional steel cables, known as tie bars, are installed to support the jib and distribute the load correctly. Every connection is carefully checked to ensure that the horizontal arm is perfectly aligned and secure. Following the jib installation, attention shifts to the opposite side of the crane, where the counter-jib must be mounted. The counter-jib is shorter than the main jib, but equally important for the overall balance of the machine. Like the jib, it is assembled on the ground and then lifted into position by the mobile crane. The component is attached to the tower head using heavy pins and bolts. Technicians verify that all structural connections are tight, and that the counter-jib is properly aligned with the main jib. Once the counter-jib structure is in place, the next essential step is mounting the counterweights. These heavy concrete or steel blocks are necessary to balance the weight of the jib and the loads that the crane will lift. Using the mobile crane, each counterweight block is hoisted individually and placed onto the counter-jib frame. Workers secure the blocks in their designated positions to prevent any movement during crane operation. The correct number and arrangement of counterweights are crucial for the stability and safety of the entire system. After the main structural elements are assembled, additional mechanical and electrical components are installed. Technicians mount the hoisting winch, trolley system, and operator cab. Electrical cables are routed along the mast and jib, and control panels are connected. Safety devices such as limit switches and load indicators are also fitted. Each system is inspected and tested to ensure proper functionality before the crane becomes operational. The final stage of the process involves thorough inspection and adjustment. Engineers and supervisors examine every bolt, pin, and structural joint to confirm that the crane has been assembled according to technical specifications. Alignment checks are carried out, and the rotating movement of the slewing unit is tested. Trial lifts are performed without load to verify that all mechanisms operate smoothly. When all tests are successfully completed, the J600 tower crane stands fully assembled and ready for service. Through a carefully coordinated sequence of lifting, positioning, connecting, and securing components, the complex machine is transformed from separate parts into a powerful working crane. The entire assembly process requires precise teamwork, strict safety procedures, and expert handling at every stage to ensure a stable and reliable final structure. The correct installation of a tower crane begins long before the steel structure is assembled on site. One of the most critical preliminary operations is the casting and accurate positioning of the embedded foundation feet for the Potain MC85B crane. This process ensures that the entire crane will stand safely, vertically, and securely during operation. The procedure follows a carefully organized sequence of technical steps designed to guarantee precision and structural reliability. The work starts with the preparation known as fundición del pobre, or the casting of the lean concrete base. This initial layer creates a clean, stable working surface on which all later operations will be performed. Once the area has been leveled and cleaned, technicians proceed to the toma de medidas, taking detailed measurements of the foundation layout. Accurate measurement is essential because any small error at this stage could result in serious alignment problems when the crane is finally erected. After the layout has been verified, workers begin the armado y anudado de la parrilla inferior, which involves assembling and tying the lower reinforcement mesh. Steel reinforcing bars are arranged according to engineering drawings and securely bound together with wire. This reinforcement grid provides the necessary tensile strength for the concrete foundation and forms the structural backbone of the entire base. The next step is the ensamble de los pies de empotramiento con el marco. The embedded crane feet, which will later receive the tower sections, are mounted onto a specially designed steel frame. This frame keeps the 4 anchor feet perfectly aligned with each other. The components are joined through the ensamble con pasadores y agujas, using pins and needles that hold everything firmly in place. This temporary assembly ensures that the geometry of the crane base remains fixed during the concrete pouring process. Once the frame and anchor feet are assembled, they are carefully positioned on the prepared foundation area, commonly referred to as the mesa. At this moment, extreme attention to detail is required. Technicians perform a thorough toma de niveles, checking the horizontal and vertical alignment of each embedded foot. Specialized leveling instruments are used to confirm that the structure is perfectly square and completely level in all directions. When the adjustments are finished, the alignment must be officially approved. This stage is known as the certificación de nivelación. Engineers or qualified supervisors inspect the setup and certify that the position and level of the anchor system comply with technical specifications. Only after this certification can the project continue to the next phase. With everything correctly aligned, the operation moves to the fundición de placa, the main concrete pouring stage. High-quality concrete is poured carefully around and beneath the reinforcement mesh and the embedded feet. The concrete must be placed evenly and vibrated to remove air pockets and guarantee maximum strength. Throughout this process, workers continuously monitor the position of the anchor frame to ensure that nothing shifts while the concrete is still wet. After the concrete has been poured and finished, the foundation is left to cure for the required period. Proper curing is essential to achieve the designed mechanical resistance. During this time, final checks are performed to confirm that the embedded feet have remained in the exact position established earlier. The last operation in the sequence is the installation of the polo a tierra, or grounding system. A grounding connection is attached to the reinforcement and anchor structure to provide electrical safety for the crane. This protects both the equipment and personnel from possible electrical discharges or lightning strikes once the crane is operational. When all these steps have been completed, the foundation is fully prepared to receive the tower crane. The precisely positioned embedded feet will allow the MC85B to be assembled quickly and safely, with the guarantee that its base is solid, level, and correctly aligned. Through this disciplined process of measurement, assembly, leveling, and casting, a reliable foundation is created, forming the essential starting point for the successful erection of the Potain tower crane. The dismantling process of the 1000 ECH40 tower crane begins with a thorough preparation stage, in which the entire structure is carefully inspected and secured. All electrical power supplies are disconnected, and the working area around the crane is cordoned off to ensure that no unauthorized personnel enter the danger zone. Technicians study the crane configuration and determine the correct sequence for safe removal of components. Because the crane is a very large and complex machine, disassembly must be carried out in a strictly controlled order to maintain balance and structural stability at every moment. The first operational step involves positioning a large auxiliary mobile crane near the tower crane. This secondary crane plays a critical role throughout the dismantling operation. Its lifting capacity and reach must be sufficient to handle heavy structural elements such as counterweights, jib sections, and the slewing platform. Once the auxiliary crane is correctly set up and stabilized on outriggers, rigging teams prepare lifting slings, shackles, and safety equipment required for the procedure. Before any major structural parts are removed, the load on the tower crane must be reduced. This is achieved by systematically removing the counterweights located on the rear counter-jib. Counterweight removal is one of the most important safety stages of the process. Each concrete or steel ballast slab is carefully attached to the hook of the auxiliary crane, unpinned from its mounting position, and slowly lifted away. The order in which the slabs are removed is planned in advance so that the crane remains properly balanced. Removing too many counterweights at once could cause dangerous instability, so technicians follow the manufacturer's guidelines precisely. After the counterweights have been taken down to the required level, attention shifts to the dismantling of the jib, which is the long horizontal working arm of the crane. The jib is normally composed of several bolted or pinned sections. Using the auxiliary crane, riggers connect lifting cables to the outermost jib section. The connection pins and bolts that secure the jib to the slewing platform are gradually loosened and removed. Communication between ground personnel and crane operators is constant during this phase to ensure that all movements are perfectly synchronized. Once the section is free, it is gently lowered to the ground and placed on prepared supports. The remaining sections of the jib are then detached one by one in the same manner. Each piece is handled individually to reduce load and to allow precise control. As the jib becomes shorter and lighter, adjustments are made to the lifting configuration. Eventually, the entire working arm is completely removed from the crane. With the jib dismantled, the overall height and wind exposure of the structure are greatly reduced, making the subsequent steps safer. Following jib removal, the counter-jib is addressed. This rear arm, which previously carried the counterweights, must also be disconnected from the slewing platform. Again, the auxiliary crane is used to support the weight of the component while technicians remove its securing pins. Because the counter-jib contains mechanical equipment, such as winches and electrical cabinets, extra care is taken to prevent damage to cables and hydraulic lines. Once free, the counter-jib is slowly lowered and transported to a storage area. With both horizontal arms removed, the upper part of the crane consists mainly of the slewing platform, operator's cab, and machinery deck. The dismantling of this central unit is a delicate operation. Rigging crews attach heavy-duty slings to designated lifting points on the platform. All remaining mechanical and electrical connections between the platform and the tower mast are disconnected. The auxiliary crane then takes the full load of the slewing assembly. When all bolts and pins have been safely extracted, the entire platform is lifted clear of the tower and carefully lowered to the ground. Depending on site conditions, this assembly may be lowered as one complete unit or separated into smaller subcomponents after it reaches ground level. Once the top structure has been removed, the tall vertical mast of the crane remains standing. The next major phase is lowering tower sections. The 1000 ECH-40 is equipped with an internal hydraulic climbing frame that was originally used to erect the crane. During dismantling, this system operates in reverse. The crane is jacked down or climbed down step by step. Technicians install the climbing frame around the uppermost mast section and secure it according to manufacturer procedures. Using hydraulic cylinders, the climbing frame lifts the upper part of the tower slightly, relieving the load on the highest mast segment. The bolts connecting this segment to the rest of the tower are then removed. The auxiliary crane attaches to the freed section and lifts it away from the structure. After the section has been lowered to the ground, the climbing frame descends to the next level, and the process is repeated. This method allows the crane to be reduced in height gradually, without requiring extremely large external lifting equipment. Throughout the tower section removal process, constant checks are carried out to ensure that the remaining structure remains perfectly vertical and stable. Wind speed and weather conditions are closely monitored, as strong gusts could create hazardous situations when the tower becomes lighter and shorter. Workers continue to remove sections one at a time until only the base portion of the tower remains. When the mast has been completely dismantled, the operation moves to the lowest part of the crane, the base and chassis assembly. Depending on the original installation, the crane may be mounted on a fixed concrete foundation, on embedded anchor bolts, or on a mobile chassis with traveling gears. If a ballasted base was used, the ballast blocks are first unballasted and lifted away using the auxiliary crane. Any remaining stabilizing weights are removed to expose the structural frame. Technicians then disconnect the base frame from its anchors. Large bolts that secure the chassis to the foundation are loosened and extracted. Hydraulic jacks may be used to relieve pressure and allow safe separation. In the case of a rail-mounted or traveling base, wheel assemblies and drive motors are disconnected and prepared for removal. Piece by piece, the final elements of the crane are taken apart until nothing remains on the original footprint. As each major component is dismantled, logistical coordination becomes essential. All parts must be organized, inspected, and prepared for transportation. Heavy-duty tower sections, jib elements, counterweights, and mechanical units are loaded onto specialized transport vehicles such as flatbed trailers and low-loader trucks. Proper lifting techniques are applied to avoid deformation or damage during handling. Smaller accessories, pins, bolts, and electrical parts are packed separately and labeled for future reassembly. The loading process follows a planned sequence so that transport vehicles are used efficiently. Larger pieces are secured with chains and straps according to road safety regulations. Because many components of the 1000 ECH40 are extremely heavy and oversized, transport permits and escort vehicles may be required. Site supervisors verify that all parts have been accounted for before the final trucks leave the construction area. During the entire dismantling operation, safety remains the highest priority. Workers use personal protective equipment, including helmets, gloves, and harnesses. Clear communication systems are maintained between crane operators, signalers, and rigging teams. Every lifting action is preceded by a briefing to confirm weight estimates, lifting points, and movement paths. Emergency procedures are kept in place in case unexpected problems arise. After the last components have been removed and transported away, the site is cleaned and returned to its original condition. Any remaining foundation anchors or embedded elements are cut flush or extracted as required. The area that once held the massive 1000 ECH40 tower crane is left clear for the next phase of construction work. Through this carefully organized sequence, counterweight removal, dismantling of the jib and counter-jib, lowering of the slewing platform, step-by-step reduction of tower sections, disassembly of the base, and final transportation, the enormous tower crane is safely and efficiently taken apart. Each stage depends on precise coordination between skilled personnel and heavy equipment. By following established procedures and using the auxiliary crane to manage every major lift, the complex structure of the 1000 ECH40 can be dismantled in a controlled manner without risk to workers, equipment, or the surrounding site. The assembly process of the tower crane begins with the arrival of all structural components at the construction site. The first operation consists of unloading the crane elements from the transport truck. Using a mobile auxiliary crane, technicians carefully lift each section and place it on prepared ground near the foundation area. All parts are inspected to ensure that no damage has occurred during transportation and that every necessary element is available for the following stages. Once the equipment is ready, the mounting of the first vertical mast section starts. This initial segment is positioned precisely on the base supports and aligned according to the project layout. After it has been correctly leveled, the second vertical section is lifted into place and connected on top of the first one. The two mast sections are then firmly anchored together using high-strength bolts and locking devices, forming the stable beginning of the crane tower. With the main mast secured, the upper pivot or slewing tip of the crane is installed. This component is attached to the top of the assembled mast and fixed carefully, as it will later allow the crane to rotate. While these operations are being completed, another team prepares the horizontal working boom, known as the jib, on the ground. The different segments of the jib are joined together in the correct order, creating a single long structure ready for lifting. The next phase involves connecting the counter-jib to the main tower. The counter-jib is hoisted by the mobile crane and attached to the upper slewing unit on the opposite side of where the main jib will be installed. After this union is completed, the tensioning cables and tie rods of the counter-jib are tightened gradually to guarantee proper stability and alignment. This step is essential to balance the loads that will act on the crane during operation. Following the preparation of the counter-jib, the first concrete counterweight block is placed into position. This initial weight provides temporary balance, while the main jib is lifted and secured. The fully assembled jib is then carefully raised from the ground and connected to the slewing mechanism. Once the jib is anchored to the tower, the technicians proceed to tension its support cables. At this moment, the temporary slings and connections used by the mobile crane are released, transferring the load entirely to the crane structure. After the main jib has been stabilized, additional counterweights are installed one by one. The second counterweight is lifted and placed onto the counter-jib platform, increasing the stability of the whole system. The procedure is repeated with the third counterweight, ensuring that each block is correctly seated and locked into place. Finally, the fourth and last counterweight is mounted, completing the balancing system required for safe crane operation. Throughout all these stages, workers continuously verify bolt tightness, alignment, and structural integrity. Communication between the assembly crew and the mobile crane operator is maintained at all times to guarantee precision and safety. When the final counterweight has been installed and all components are secured, the tower crane reaches its complete configuration. The machine is then ready for electrical connections, testing procedures, and eventual commissioning for lifting tasks on the construction project. The C10 Cartagena project represents one of the most demanding and comprehensive heavy lifting and transport operations carried out in recent years in the Spanish industrial sector. Located in the strategic port and industrial area of Cartagena, this project required the coordinated movement, positioning, and installation of more than 50 large and complex components destined for a major industrial facility. The scale of the operation, together with the weight and dimensions of the equipment involved, made it essential to rely on a highly experienced engineering and lifting specialist. For this purpose, the Heavy Lift Division of Eurogruas was entrusted with the complete execution of the project. From the very beginning, Eurogruas assumed full responsibility for all engineering aspects related to transport and lifting. This included detailed route studies, structural calculations, load distribution analysis, crane configuration planning, and the design of specific lifting procedures for each individual component. Every element of the project required careful preparation to ensure that the movements could be performed safely and efficiently. The complexity of the operation demanded not only advanced technical knowledge, but also precise coordination between engineers, operators, and logistics teams. In order to carry out the numerous lifting tasks involved in the C10 Cartagena project, Eurogruas mobilized an impressive fleet of high-capacity equipment. Among the main machines used were several lattice boom cranes of exceptional lifting power. The Liebherr crawler crane, with a maximum capacity of 1,350 tons, played a central role in the heaviest and most critical lifts. This crane, known for its enormous stability and reach, was essential for positioning oversized modules and reactors with extreme precision. In addition, two 600-ton class cranes were employed, the Terex de Mag TC2800-1 and the Terex de Mag. These machines provided the necessary flexibility and strength to perform tandem lifts and to handle components in areas with limited space. Transport operations were equally challenging. Many of the units to be installed had extraordinary dimensions and weights that made conventional transport methods impossible. For this reason, Eurogruas utilized self-propelled modular transporters manufactured, configured with 72 axles. These advanced vehicles allowed massive loads to be moved smoothly and safely within the project site, even in confined or complex environments. Additionally, conventional modular trailers from GOLDHOFER with 30 axles were employed for other transport tasks, demonstrating the versatility of the logistics strategy. Numerous telescopic cranes with capacities of up to 700 tons were also brought to the site to support auxiliary lifting operations and to assist in assembly work. Beyond the main cranes and transporters, a wide range of auxiliary equipment was required to ensure the smooth progress of the project. Self-loading trucks, special transport vehicles, and concrete pumps were integrated into the daily operations. Each of these elements contributed to the overall efficiency of the project, allowing teams to adapt to changing conditions and to meet tight deadlines. The coordination of such a large amount of machinery and personnel represented a major organizational challenge, successfully managed through detailed planning and constant communication. Safety was a fundamental priority throughout the entire project. Every lifting and transport operation was preceded by rigorous risk assessments and method statements. Operators and rigging teams followed strict procedures designed by Eurogruis engineers, ensuring that each movement was carried out under controlled conditions. The combination of high-quality equipment, experienced professionals, and advanced engineering made it possible to complete the project without incidents, despite the technical difficulty involved. The C10 Cartagena project stands as a clear example of what can be achieved when engineering excellence and operational expertise come together. By managing all aspects of transport and lifting, Eurogruis demonstrated its capability to handle large-scale industrial challenges with professionalism and precision. The successful installation of more than 50 major components required not only powerful machinery, but also intelligent planning, innovative solutions, and effective teamwork. In conclusion, this project highlights the vital role of specialized heavy lift engineering in modern industrial development. Through the use of world-class cranes, sophisticated transport systems, and highly trained personnel, Eurogruis was able to deliver a complex operation that met the highest standards of safety and efficiency. The experience gained from the C10 Cartagena project further reinforces Eurogruis' position as a leading company in the field of heavy lifting and oversized transport, capable of undertaking the most demanding projects anywhere in the world.